What's up, class 9th champions, class 9th ninjas? So welcome again on your favorite channel, Diksha Vedantu CBSE English, and this is your maths teacher, your Sonu Sir. So my dear champion, as I promised you guys in my last live session that I will be giving you one short video also in recorded format. Okay, so I have come up with my promise and I'm going to fulfill my promise today. So my dear champion, this video is going to be one shot of chapter number 4, exploring algebraic identities. But my dear kids, I have divided this one shot video into two parts, part 1 and part 2. But in part 1 video, I want to ensure you guys almost 60% of the chapter will be covered, everything. Right? But to get the concept clarity of entire chapter, complete chapter, you should watch both the videos, part 1 and part 2 videos, so that you can feel confident in this chapter, exploring algebraic identities. So without wasting a moment, let's start exploring algebraic identities, chapter number 4 from your Ganit Manjari. So my dear champion, first let me show you a short overview of few identities, algebraic identities, very widely used identities, very popular identities, because you guys are studying these identities for the first time in your life in class 9th presently, but these identities will be reflecting now in your higher standard classes, whether it is in class 10th, 11th, 12th, everywhere, and not only in maths, in physics also, sometime in chemistry also, right? So these are very important identities, my dear. Okay, so the first identity is a plus b whole square, a square plus b square plus 2ab, a minus b whole square, a square plus b square minus 2ab, a square minus b square is equal to a plus b, a minus b. This is the square of trinomial a plus b plus c whole square, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So there are almost 9 algebraic identities. They are the most popular and most widely used identities are there in the field of academics. So my dear, now the most important question might be coming in your mind, sir, how these identities are derived? Can we also derive these identities? What is the reason behind it? Are they really, correct identities or not? So my dear, let's solve these identities. We are going to prove these identities. So one by one we will be exploring every identities, how they came, how they derived, and then after understanding everything identities, we will be solving the questions based on these identities. But before jumping to the question directly, my dear, better to understand the concept. So you should understand the each and every identities in detail form, right? Then only you will be able to solve the question from your NCERT confidently. And this is my teaching methodology. When I used to start mathematics, of whether it is of class 9th, 10th, 11th, 12th, whatever, so I used to give you the basics clarity. Once your basic is clear, concept is clear, my dear, you can beat anyone in maths. Right, everything will be in your control, right? So let's start the chapter algebraic identities. So first question here is, what is called algebraic expression? Let's keep the identities aside. Let's first understand the algebraic expression. What do you understand by algebraic expression? So let me tell you, my dear champion. So basically, algebraic expression is the phrase of combination of variables, constant, and some operations. Operation means plus sign and minus sign is basically called operation. So let me show you. So first understand what are called variables. So my dear champion, variables are basically a letter in the form of x, y, z, whose values are not fixed. They can be anything as per the situation, as per the condition. Sometime x will be coming as 2, sometime x is equal to minus 4, sometime y is equal to 4, sometime y is equal to 3 by 2, whatever. So their values are not fixed. So we generally represent variables with the help of a letter, alphabetic letter. So we take generally x and y and z also. So basically variables are x, y, z, etc. It means that their values are not fixed, and that's why this is called variable, because their values are keep varying. Now the second thing is constants. Constant means what? Constant means fixed. If I ask you, what is the height of this smartboard? So if you measure the height of this smartboard using any measuring tape or whatever you have instrument, so the height of, let's suppose the height of this, the width of this screen is of let's say 30 centimeter. Just suppose. So after 2-3 days, 1 year, after 5 years, after 10 years, this height will remain as it is. So this height is fixed. So this is called constant. So my dear, similarly, all the numbers, all the numeric numbers, 2, 3, 5, 6, 100, and these all are constant, because if I write here 5 will not become 6 on the next day by itself, until and unless we are not doing any mathematical operation to that. The 5 will remain as it is in its original format. So 5 is 5. Similarly, 6, 8, these are the constant. I hope you are getting my point. And if I talk about here operations, so basically operations means sign, plus sign and minus sign are called operations. Now if we combine a variable, constant, and make a mathematical phrase, a systematic format, that format is called algebraic expression. Let me show you. If I am taking a constant 5, a variable x, and one more variable y, my dear, so this 5x plus y is called algebraic expression. So this is a mathematical phrase which is formed by the combination of variables, constant, 5 is constant, but 5 is called coefficient because that constant is attached with a variable, so that is called coefficient, but 5 is constant also, and this operation plus sign is there. Now let me show you everything here. Let's name everything here. So I'm making box here, and my dear champion, listen. So here x and y, they both are variables. I hope you are getting my point. The yellow color is variables. And here the 5, this 5 is constant. Yes, constant. But it has a special name because that 5 is attached with x. That 5 is attached with x. It is multiplication with variable. So whenever a constant value is attached with a variable, they got a special name, and which is called coefficient. So basically this is coefficient. This is coefficient of what? X. Yeah, this is constant, but it has special name. This coefficient, right? And here the coefficient of y is, if there is nothing, it means that 1 is there. And now my dear champion, I'm using here pink color. So this family and this family, both the families are called terms. Yes, my dear. So the family members which is separated by operation, plus minus, whether it is plus or minus doesn't matter. So the families which all are separated by the operations, whether it is positive sign or negative sign, those families are called terms. So in any algebraic expression, there may be a single term, there may be 2 terms, 3 terms, 4 terms, whatever. I hope you are getting my point, and this system is called algebraic expression. Clear, everyone? Now moving ahead. Okay, so now let's talk about types of expression according to number of terms. So I'm going to give you types of expression according to number of terms. Okay, number of terms. So the first expression here is, for example, my dear, 4x. 4x means there is only one family. There is no any operation sign, whether positive or negative. Only one family is there. So such algebraic expression are called monomial. Second comes up here is, if this is 4x and I have added one more number, let's say this is 2y. 4x plus 2y. 4x plus 2y. 4x plus 2y. So this is called binomial. Why binomial? How many terms are now? 2 terms are. This is binomial because 1 term and 2 term. I have already told you what are called terms. The family members which are separated by operation. Okay. Now third comes up here is, for example, 3x plus y minus 3. Now can you see here? How many terms are there? See, whether it is pure constant doesn't matter. You just look at the operations and how many family members have been separated by the operation. So 1, 2, 3. So such expressions are called trinomials. I hope this is clear to you. Monomial, binomial, and trinomial according to number of terms. Right? And how many variables here? X and y, 2 variables. So this is monomial in single variable, this is binomial of two variable, and this is binomial, a trinomial of two variables, because x and y both are variables. I hope this is clear to you all. So such expressions are called, algebraic expression. Moving ahead. Okay. Now let's talk about very important concept, equation and identity. Now I have already seen a lot of students are having confusion regarding equation and identity. They are not able to understand the basic difference between equation and identity. So let me show you, my dear champion. Please focus on board. This is very important. So my dear, if we talk about equation, listen. So equation are those algebraic expression in which we calculate the value of variables. Listen what I'm saying to you guys. Equations are those algebraic expression in which we are keen to find the values of variable present there. It means that there will be only one solution. Let me show you. For example, this is x square minus 1 is equal to 24. Now look at this. Basically, this is an equation. Why this is an equation? Because only one variable is in square form and constant 24 and constant minus 1 is there. So here this equation, this expression indicates that we want to find out the value of x which will satisfy this whole scenario. I mean, if we put anything here, the right side is equal to 24, so left side also should be equal to 24. So we want that value which would satisfy this situation, right? So we are looking for that value. So there will be only, if quadratic polynomial is there, quadratic equation power 2 is there, so there will be two solutions. We will be talking about these things later on. First, basic, just understand the initial things. So if we solve this, so we can shift this minus 1 that side. So x square will be equal to 25. Now if we remove square sign, 25 will go under root. So we have x is equal to plus minus 5 because 25 is a perfect square. So plus minus 5 are the values of x which will satisfy this equation. So we got this solution, this value. Now moving to identity. What does it mean by identity, champion? Focus on it. Identity. What are called identity? So basically, identities are also algebraic expression, but they allow any value of x and y, to satisfy RHS and LHS. Let me show you one example here. If we take an identity a plus b whole square, I mean x plus y whole square, which is equal to a square x square plus y square plus 2xy. Now look at this. This is RHS and this is LHS. If you put any value of x or any y, the result at RHS and the result at LHS will remain equal to each other. It means that RHS and LHS will be verified. You put any value, yes my dear champion, if there are 100 students in a class 9th, if 100 students are putting different values of x and y according to their interest, at every value of x and y, this will be satisfying. So such expressions are called identity. So let me show you an example. So my dear, let's put here in this equation, x I'm taking 2 and y I'm taking here 3. Let's put here at RHS and LHS. Now solve this. So I'm solving here RHS first. RHS. So RHS is equal to x square. So this will be 2 square plus y square, which is 3 square, plus 2 into x. It means 2, it means 3. Now solve this. 2 square will be 4, 3 square will be 9, and this is 2 to 4, 3 12. If we solve this, we are getting 25. So I hope this is clear to you. RHS is 25. Now put same values of x and y in LHS. Let's check what is the result you are getting here. So LHS will be x plus y whole square. So we can put here 2 plus 3 whole square. My dear champion, 2 plus 3 is 5. Oh my God, 5 and 5 square. This is 5 square. 5 square is 25. Some student, what they used to do when they do square, because they multiply the numbers 5 to 10. My dear, don't do this. 5 square means 5 itself is multiplying 2 times with itself. So 5 into 5 will be 25. Can you see here? Can you see here, champions? Can you see here? What is your RHS 25? What is your RHS? RHS 25, LHS 25. It means that this is satisfying. You put anything X, anything Y, they will be satisfying at every value. So such expressions are called identity. So equations true only for X, that is we have, and identity trues for all X and Y. So I hope you have understood the concept of identity in expression. Now look at the question here. You have to give answer equation or identity. So this is what? Equation. Why? Because we have to find out the value of X at which this condition is satisfying. So there will be only one solution because power is 1. Now if we look at this, a square minus b square is equal to, so we have written RHS is the expanded form of this identity. Now if you put A and B whatever at RHS and LHS, both will be satisfying. So this is identity, right? And this is equation. I hope this is clear to you everyone. Now you can see here your turn. So this is question here, and an equation identity. Obviously this is equation because here this will not be satisfying at every X. There will be only one solution of X which will be satisfying RHS and LHS. So this is equation. Okay, moving ahead. Okay, so let's explore basically. Let's explore the identities, algebraic identities, and in this Q we have first identity, a square of sum, which is a plus b whole square. So my dear champion, a plus b whole square is equal to a square plus b square plus 2ab. Please keep this identity in mind. Now you might be thinking, sir, why should we trust on you? We don't believe, we don't trust on you. This identity is right or wrong. Could you please prove this identity in simple manner? Show us this identity is correct or not. So let me show you. Let me prove this identity in very magical way. So listen, champion. So to prove this identity, what we required, listen. So draw a line here. This is a line, okay, of side A. I have drawn a line of side A, right? Draw a line of side A. Now produce this line till B. So this length is basically B. So this complete line has become A plus B. I hope no problem is there. This complete line has become A plus B. You might be thinking, sir, what you are doing here? Listen, champion. This is A plus B whole square. So A plus B whole square, if you remember, something square is also resembling like area of a square. So my dear champion, to get this format, we want to, I am drawing a square, draw a what? Square, draw a square of side what? A plus B. Because if you have drawn a square of side A plus B and take area, so the area will look like A plus B whole square, side square. Because we know the area of a square is equal to, I hope we all know area of square. What is area of a square, champions? The area of a square is equal to side square. So if you take a square of side A plus B, so the area of a square will become automatically A plus B whole square. So that's why I have drawn A plus B. Now let's make a square of this same side. So here, let me draw. Line should be perfectly vertical. So this is here one more side, this is here one more side, and this is here one more side. Okay, so we have here A plus B square of side A plus B. Right, champions? A plus B. Now please observe. This side A was produced to this point by increasing side A with B. This was the increased side in A. So now let's draw a square here inside the bigger one of side A. So this square will look like this. Can you see here? This square will become, this is B, and this is B. I hope this is clear to you all. So this small square is of side B. So area of this square will be B square. I hope clear to you all. Now do one thing. Let me use your green color, or I can use your green color. Now do one thing. Join this corner from there and this corner from there. This. Now, my dear, if I ask you to find out the area of this entire square, so the area of this entire square will be equal to area of this compartment, area of this compartment, area of this compartment, which is, let's say this is 3, and area of this compartment. You agree? If you calculate the area of this entire square, that will be equal to area of compartment 1, area of compartment 2, area of compartment 3, area of compartment 4. Clear? Now let's find out. So I'm writing here area of square, I'm writing in bracket side A plus B, of side A plus B will be equal to area of first compartment, area of second compartment. I'm missing the compartment because I don't have a lot of space here, so you guys can write in your copy. Area of third plus area of fourth. Now the magic is about to come in front of you. Come on, champion. Area of first. Look at first. Where is first? This is first. Can you see here? This is first. And this first having this side and having this side. And this side is equal to A, because this is A. And this is also A. This is also A. This is also A. And if this is A, so this will be B. This will be B. And this is A. I hope everything is clear to you all. Some of you might be confusing here. So basically, my dear, A plus B is the entire side. Don't get confused. This is the A plus B. This is A plus B. This is A plus B. Right, and here this is A plus B. Clear, everyone? So what will be area of first compartment? Area of first compartment will be equal to A square. Come on, yaar. Because that is a square. Plus area of compartment 2. Compartment 2 is rectangle. This is a rectangle. And we know the area of rectangle is length into breadth. So we can write here AB. AB, because length is A and this breadth is B. Plus area of compartment 3. This is compartment 3 and here we have B square, because there is a square of a small side. And area of fourth. Fourth is also a rectangle. Can you see here? And the length is A, breadth is B, so this will be AB. Wow! Wow! A square plus B square and plus AB, 2AB. So we have A square plus B square plus 2AB, and what we have solved? This is area of a square side AB, the bigger circle, square. So bigger square has side AB. So what will be its area? That will be A plus B whole square. So, champion, we can write area of a square. Okay, let's write in initial. A plus B whole square. So we have A plus B whole square is equal to A square plus B square plus 2AB. We have proved. This is very important. This is very important, champion. The first identity, we have proved A square plus B square plus 2AB. This is the beauty of maths. I hope this is clear to you all. So based on this identity, we have one question, one example that we have solved. 5x plus 2y whole square. So A square, it means 5x square plus B square 2y square plus 2AB, and this is the result. I'm giving you one question to you from exercise 4.1, and the question is expand. So we can consider as x A, and we can consider as y, complete y, x plus y whole square. So the answer will become A square. Expand means we have to apply A plus B whole square identity. A square plus B square plus 2A into 4y. Now solve the result. So 7x square will become now 49x square, and this is Some student, what they used to do, 4 to the 8. Yes, they will be writing there 4 to the 8. Come on here, don't do this. 4 to the 8 will not the correct answer. 4 square means 4 into 4. 4 is multiplying itself by 2 times. So 4 into 4 will be 16. And y will also go in square form. So 16y square plus 2 into 7 to the 14 and 14 4 to 56. So this is equal to 56 xy answer. So we have expanded this. I hope this is clear to you all, my class 9th champions. Please write these things in your notebook if possible, or if you want to take screenshot, come on, do it. Okay, moving ahead to the next identity. Wow. So this is again, my dear champion, one more thing I want to tell you. See, if a plus b whole square is there, you can expand in this format. If the expression is already in this format, so you can also write in backward direction. You can apply back gear, backward. So if the expression is in this format like this, so we can expand this. But if the expression is already expanded, so we can apply the back gear. We can write in this format, which is called factorization. Let me show you. So look, spotting perfect square. So my dear, reading the identity backwards. Can you see here, backwards to factorize? So if the identity is already in this format, a square plus b square plus 2ab, so we can write this. Or we can also write this a plus b whole square. So both are interchanged, both are possible here. So let me show you one example. So can you see this question here? This is 36x square plus 12x plus 1. So my dear, 36x square can be written as 6x whole square, and this 1 can be written as 1 square. And this will automatically come into AB format, because we are considering 6x A and 1 as B. And if you write 2 into A into B, this will automatically come 12x. So this is A square plus B square plus 2AB. So we can write in this format, 6x plus 1 whole square. Let me solve this question for you, everyone. So look at your turn, NCERT exercise 4.2. This question is from your NCERT textbook. So let's solve this question. The question is 9x square plus 24xy plus 16y square. Right, everyone? So my dear champion, 9x square can be written as 3x whole square. And my suggestion would be, I would like to suggest you, don't touch this middle term, central term. Keep that term as it is for a little while and do this. So solve the last one. So this 16y square can be written as 4y square. Why I have suggested you to don't disturb this central term? Let me show you. Now look, this is a square and this is b square. So the central term, the middle term should be 2ab. So you can directly write 2a will become 3x and b will become 4y. Now check this, multiply. 2 3 ja 6 and 6 4 ja 24. Oh my god, same is coming here. So if you write first and third term, the central term will automatically come. You don't need to put your effort and energy in that. That will automatically reflect there, what you should write, right? So this is a square, b square and 2ab. So we can write, we can apply reverse break. So x is basically 3x and at the place of y, we can write 4y. So this is 3x plus 4y whole square is your answer. All right, everyone. I hope this is clear to you all. Moving ahead. Next. Okay. Wow. The next is a square of a difference. Wow. So in previous slide, we have just studied about a plus b whole square. Now a minus b whole square. So let's have a look to the identity first. Then we will prove it also. So a minus b whole square is equal to a square plus b square minus 2ab. So now we can apply this identity to solve the questions. For example, evaluate 29 square mentally. Mentally means without using pen and pencil. Solved in your mind. So 29 can be written as 30 minus 1. 30 minus 1 whole square. So 30 is A, 1 is B. So that look like A minus B whole square. So 30 square will be 900. 1 square will be 1. So 901 minus 2AB. It means 2 into 30 into 160. So 901 minus 60 will be answer. So 900 minus 61, 901 minus 60 will be 841. So we can solve the questions mentally also without using pencil or pen, if you remember the identity. So let's prove this first, how it came. Okay. when we prove the identity, na, it give you confidence. It give you, yeah, this is powerful. But if you just mugging up the formula, if you are just memorizing the identity without knowing the backstory, so it will be, I mean, it will be hitting you inside, like you are just doing the things for formality. You don't have clarity on this identity, how it came, how it derived. But despite of without knowing the basic concept of this, how it came, how it derived, if you do the question, na, it look like that you are doing something very irrelatable. But when we understand the identity proof and all, it feels like that, yeah, we have proof also, this is absolutely correct identity, this is powerful identity. After that, solving the question will be making you fun there, right? So let's start a minus b. Okay, so to prove this identity, again we required a side here of a length. So this is, I have side square of a length. So mind here, this entire, this complete, me use, yeah, white color itself. So this complete is A. This complete side is A. But we required A minus B. As we required a square. What does it mean by A minus B whole square? To get this expression, we required a square of what, my dear? Side what? A minus B. Then only if you write the area of that square, the area will become A minus B whole square. So to get this expression, we required a square having side A minus B. Okay. So we have A. Is it clear to you? Now this is B here. This length is B. This length is B. My dear champion, if entire this complete line is A and this portion is B, so what will be the remaining? Come on, what will be the remaining? So remaining side, this remaining side will become A minus B. Wow. Is it clear to you all? Is it clear to you all? Okay. Now, my dear champion, we all required square of side A minus B. So then only we can write A minus B whole square. So we have A minus B. Let's draw. Now let's draw square there of side A minus B. So this will be here, this, and let's increase the size here according to A minus B. Now one more side we have here is this, and one more side we have is this. Wow. So this is the square of side A minus B, right? Okay. Now, my dear champion, if you have A, this entire side, so let's draw the square of side A. So my dear, let me do one thing. If this is a square of side A minus B, so this will be here A minus B, and this is also A minus B, right? But the magic is about to come in front of you. So let's increase this by here. Now let's increase this by here. Now here, right? And this. Now, what I have drawn here? A square. Why I'm drawing a square? I need a line simply. So I need a line here. So this will be the line here. This will be the line here. And this will be the line here. Right, champions? Okay. So we have. Okay. Now, listen everyone. So the structure is ready. So this square is of side A minus B, and the bigger square, the larger one, is of side A. So what will be the scenario? Come on here. This is A. Now do one thing. Join this point from this side here. Oh, wow. So if this is B, then it has to be B. If this is a minus b, so it has to be a minus b. And if this is b, this is a minus b, then it has to be b here. This, because a minus b plus b will be cancelled, so entire is a. And this complete is a. Right, everyone? Everything is ready. Now we want area of this. We want this area. Let me share this. We want this area. Area of shaded part. Can you see here? Area of shaded part. So if I write here, area of shaded portion will be equal to what? Area of shaded portion will be equal to what? Let's say I'm calling this as 1 and this as 2. So my dear champion, to find out the area of shaded part, we can subtract the area, sum of area of first and second from the bigger square. Agree or not? So area of shaded part will be equal to area of largest square, I mean the bigger one, minus what? Area of first part plus area of second part. Right, everyone? Have patience, have patience. I'm solving this for you, everyone. So area of this what? Area of shaded portion. So shaded portion is a square of side a minus b. So what will be the area? This will be a minus b whole square. Oh my God, it look like we are approaching to our target. Okay. Now area of largest square, which is the biggest one, side a. So area will be a square minus area of first part. Where is first part? This is the first part, and the first part is of side a and this width b. So what will be area? AB plus what will be area of second part? Where is second part? Second part, this is the breadth and this is the length. Breadth, length. So length is a minus b. So we can write b into a minus b. I hope this is clear to you all. Now solve this. A square AB and this is plus AB, and here b into b square. Now solve, open the bracket. A minus b, a square, and this is minus plus, and AB and AB will be 2AB, AB 2AB, and both are in positive form. But when we bring out of the bracket, so plus minus will be there. So minus 2AB and minus plus b square. Oh my God! A minus b whole square is equal to a square minus 2ab plus b square, which is absolutely correct, and this is the proof. I always teach maths with proof. I never teach anything in mathematics randomly without any proof, anything. No. I don't teach anything. Study everything which is relatable, which is absolutely mathematically proved, everyone. And this is the power of maths. You can put anything A, B at the right hand side and the left hand side, they will be satisfying. They will be verified at any value of A, at any value of B. Let me show you an example. Let me show you. So let's do one thing. Put A as 3 and B as 1. So 3 minus 1 whole square. So here also this will go 3 whole square minus 2 into 3 into 1 plus 1 whole square. B is okay. Let's prove it. So 3 minus 1 is 2. 3 minus 1 2, and 2 square will be 2 2 is 4. I'm not multiplying. I'm multiplying 2 itself by 2 times. 2 into 2 is 4. Now here 3 square is 9 minus this is 2 3 is 6. 2 3 is 6, 1 is 6, and this is plus 1 square 1 is 1. So this is 4, and can you see here 9 is plus, 1 is plus. So 9 plus 1 is 10 and minus 6. Oh my God, can you see the result? Both the results are equal to each other. Hence the algebraic identity is powerful, absolutely proved. Now we can use this identity to find out the value of 29 square. 29 square we can write 30 minus 1 as you have written 29 as 30 minus 1, now this has become identity of a minus b whole square, because if you compare, at the place of a we are getting 30, at the place of b we are getting 1, so 30 minus 1 whole square. Now we can apply identity. So I'm giving a question here. I think this is not visible to you, so the question is 79 whole square. How to solve this question? My dear, 79 can be written as 80 minus 1 whole square. Now 80 is a, 1 is b, solve that, applying identity. Moving ahead. Oh, wow. The next identity is a square of a trinomial, squaring the sum of 3 terms. 1 term, 2 term, 3 terms. 3 terms are adding up and we are squaring that. So this is a square plus b square plus 2ab plus 2bc plus 2ac, 2ca. Now again same question. Sir, I don't have trust on your teaching method, on your proof and all. I don't have trust on this identity, whether this identity is correct or not. Let me show. Sir, please show us the proof how this identity has derived. So this is the proof, champion. So I'm not going to draw the separate diagram again. Diagram is already given. So let's use this diagram itself. So my dear champion, this is very important derivation. So let's prove this. So again same thing. If this is a plus b plus c whole square, so do one thing to get this identity, to get this format. Just to get this format, what we can do? Draw a what, champion? Square of side what? Of side a plus b plus c. This is the only way. Draw a square of side a plus b. And once you have drawn a square of side a plus b, now if you write the area, so what will become the area? Area will be look like a plus bc whole square. Are you getting my point? So to get this expression, LHS side, we need a square. We need a square of side a plus b plus c. And that's why, can you see, champions? Here we have drawn a side of a plus b. See, this width is a, this is b, and this is c. And if this is a portion, b portion, c portion, so this entire is equal to a plus b plus c. And same here, this side, a plus b plus c, a plus b plus c, a plus b plus c. So this square will be of side a plus b plus c. And if you write the area of that square, it will look like a plus b plus c whole square. Don't look ahead. Don't look far. Just stay here. Enjoy the present time. Everything will automatically arise there. Everything automatically will reflect. Don't worry. Just focus on basics only. So we want a square of side a plus b plus c. Now, my dear champion, look at here. Let me use green color. I think green color will be visible. So my dear, if this is a, so this square has become side of a. And if this is b, this is b, but this is a here. So this is a, this is b part and this is a part. Both are not equal. So this is a rectangle of side b and this is a. So area will be AB. This is A here, this is A here, and this is also A. Similarly, my dear, if this is B and if this is A, so it has to be B. So this is B. And it has to be C. And if this is B, so this will also be B. And if this is also B. Wow. So this has become a square of side B. So the area will be B square. Similarly, this is C, but this is A. So this is a rectangle. So that's why area is AC. And if this is B here, and here this part is C, so it has to be C, C, C. So we have this rectangle of side B and C, the area will be BC. And we have square here of side C, so the area will be C square. And here this is B, but this is C. This is B, this is C, so the area will be BC. And here, if this is B, this is A, this is B, this is A, so this is a rectangle, and that's why area is AB. And here is C, because C, 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 so this is also C, and here is A, so this is C, and this is A, so the area is AC. So we have distributed entire square into 9 parts. First, second, third, fourth, fifth, sixth, seventh, eighth. So the area of the bigger square, if we write here, area of a square of side, what? A plus B plus C of side A plus B plus C is equal to what? Is equal to what? Area of this plus 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 this. We have to add all the 9 portions. So let's add. So A square plus this is AB plus this is AC plus this is AB plus this is B square and BC plus AC BC C square, AC BC plus C square. I hope you guys have understood now. Now do one thing, take a square family all together. So this is A square plus B square plus C square, A square B square plus C square plus, can you see here, what is this? AB, and here what is this? AB. AB plus AB will be 2AB. Now next, what is this? BC. What is this? BC. BC plus BC will be 2BC. Now this is what? AC. This is what? AC. AC plus AC will be 2AC. We can also write 2CA, because when this is ending with C, if we start this expression as C, so it will look like little relatable and easy to memorize. So A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Now can you see here? A square plus same identity is there. Hence proved. Hence proved. I hope you guys have understood. So example is there. Find the example value of 119 square. 119 square. So 119 can be written as 100 plus 10 plus 9. Our target is to write the number with 1 and 0, so that the calculation will become comfortable. We can square 100 easily, we can square 10 easily. So that's why we convert the number in the form of 110. So A, 100 is A, B is 10 and 9 is C. So A square plus B square plus C square plus 2AB. We can take 2 common from all these family. We can also write the formula identity A square plus B square plus C square, taking 2 as common. So this will look like BC plus CA, taking 2 common. So this is also easy method. Okay, so by solving that we got the value here. So I'm giving you one question here. Expand. We have to expand here this. This is X Y plus Z. A plus B plus C whole square. A plus B plus C whole square. This is entire is A, entire is B, entire is C. Let's do this question for you. Okay. So A square, P square plus B square, 3Q square plus C square. At the place of C we have 7R. They can be anything, but the identity should look like this. Inside the bracket they can be anything, but the identity should look like this. A plus B plus C whole square. So plus 2, we can take 2 as common here. AB, so P into 3Q, AB plus BC. Where is B? B is 3Q. And C is 7R. Plus CA. C is 7R. And A we have as P. Now solve this. So this is P square. 3Q square is 9Q square. 7R square is 49R square. 7 square 49. Don't write 7 to the 14. Some student used to write 7 to the 14 also. My dear, 7 square means 7 is multiplying with itself 2 times. 7 into 7 will be 49. So 49 square plus 2 we have already taken common. So this is 3 PQ, P into Q, PQ. And this is 7 3 are 21. 21 QR. And here is 7 1 is 7 RP. So this is the answer. We have expanded this bracket, so the answer is this. I hope this is clear to you all, champion. Moving ahead, moving next. Okay, so wow, the next identity we have A square minus B square is equal to A plus B, A minus B. Very interesting identity. again, as our rule, let's prove this identity, whether this identity is correct or not. So my dear, look here, just imagine, I just suppose, listen, this is a square. What does it mean by a square? If we make a square of side A and taking the area will look like a square. Wow. And what does it mean by b square? If we take a square of side B, the area will look like b square. And if we subtract a square minus b square, we will get this result. So look at the diagram here. So here, my dear champion, this is given to you. This bigger square, we have to take this square of larger side, because b square is subtracting from a square. So the square of side B should be smaller than a. Then only we can subtract. So we have this a, the square of side A, this one. So this will be also a, this will be a. But my dear champion, if I ask you one thing, what will be the measurement of this? This will be a minus b. Agree or not? Because this is b square, so this is b here. And this complete is a, the complete side is a, so a minus b, so this will be a minus b. Clear? Okay. Now do one thing. Let's draw a line here. This green color portion is equal to a square minus b square, because a square is the complete area, minus subtracting this red portion, we are getting this green area, and we want to calculate that. So do one thing. Let's join this point, this here. Let's say this is first compartment and this is your second compartment. Right, everyone? So my dear champion, if we apply here area of square has side A minus area of square has side B is equal to what? Is equal to area of one part plus area of part 2. I hope this is clear to you all. See my dear, this is area of side A, complete, minus B, so this will be this plus this. Why I have drawn this? Because after drawing this line, the part is looking like symmetric and this part 2 is looking like symmetric as a rectangle. If rectangle is reflecting to you, now you can write the formula for rectangle of area formula. So look at this is area of square, so this will be a square and minus b square, right? Area of square has side A square, minus area of square side B square. Now look, area of part A. What will be area of part A? This is a rectangle here. And we have this. What will be the value of this? A minus B. Right, this is A minus B. This is, let me use here different color, pink color. I'm using here pink color. So here is A minus B. This is right. So what will be area? And we have this. This is B. So this is B. Right. And if we talk about the bigger rectangle, this one, what is this? This is B. So it has to be A minus B. Width, and this is the length. We have already this as A. Now we can write the area formula. What we can write here? Champion, area of part 1, which is this compartment, and the area will be length into breadth. So B into A minus B plus area of compartment 2, and area of compartment 2 is length into breadth, A into A minus B. A into A minus B. Can you see here? A minus B and A minus B is common in both. Can we take common? We can take common. A minus B. So these two will be combined. Oh, wow. A square minus B square is equal to A plus B minus B. A plus B minus B. Let's interchange. Otherwise, there is no difference between both. So we have proved A square minus B square is equal to A plus B, A minus B. My dear champion, both the brackets are in multiplication form. So whether you write A plus B first A minus B second or A minus B first, A plus B second, doesn't matter, the result will remain same. This is important. Now you might be thinking, sir, let's prove this is satisfying or not. So let's prove. So I'm taking A as 9 and B as 4. So let's take A as 9 and B as 4 and put RHS, LHS. So let's find out RHS first. So this is RHS, A plus B. So this is 9 plus 4 and LHS 9 minus 4. 9 plus 4 is 13 and 9 minus 4. This is 9 minus 4 is 5. So we have 65. 9 plus 4, 13, 9 minus 4, 5, 13, 5, just 65. Now let's prove LHS. Where is LHS? So LHS is A square. So A means 9 square minus B square. B is 4. 4 square. Solve this. This is 81 and 4 for just 16. Now 81 minus 16 is equal to 5. Oh my God, hence proved. Hence proved. 65, 65. It means that this identity is also powerful identity. Now we have one question here. What will be the value of 102 into 98? So my dear, 102 can be written as 100 plus 2 and 98 can be written as 100 minus 2. The condition is that if you are writing A square minus B square, A plus B and A minus B, they both should be same. Yes, my dear. So here you can see this is 100 plus 2 and 100 minus 2. It means that this identity is fulfilling here. So if this is already in expanded form, so we can write A square, 100 square, A square minus 2 square. So 100 square means we need to put 2 more zeros. So 10,000, 2 square is 4. So 10,000 minus 4 is 9,996. This is the answer. Can you see here this question? 2s plus 7 and this is 2s minus 7. So this is A plus B, A minus B. So we can apply identity. We can see, my dear, you can write A square minus B square as this, or you can also apply back here. This identity can also be written as this. So this is already in expanded form. So we can apply this as 2s whole square minus 7 square. So 2s square will be 4s square minus 7 square is 49. This is the answer. 4s square minus 49. This is the answer. Clear, everyone? Moving ahead. Oh, wow. Oh, powerful. Now product of x plus a. So x is variable and a and b are any number, any constant. So multiplying two binomials visualized with algebra titles. So this is very interesting. So my dear, when you multiply x plus some number and the other bracket is x plus another number, so the expression will expand in this format. Let's do a question here. X plus 3 and x plus 4. Now this is x square as it is. So x square plus these two numbers will be added. 4 plus 3 into x plus the last term will be the number will multiply a into b. So this is 3 into 4. In center, both the numbers are adding with each other and x is in multiply. At the end, both the numbers are getting multiplied. Now solve this. X square, 4 plus 3 is 7, x and 4 3 are 12. This is the answer. Same question here also. Right? Now, the question here is how it came, how we can derive this. So, my dear champion, you can see here, this is x plus a and this is x plus b. So, if we draw a rectangle, please focus on my words. If we draw a rectangle, one side x plus a and the adjacent side x plus b, x plus a, x plus b, we can prove this identity. So let's, this question we have solved this question, solve this identity based on this question itself. So my dear champion, if we imagine x plus 3, this x plus 3 as a length and x plus 4 this as breadth, right? So look at the diagram. Look at the diagram here. This is x plus 3. So 3 can also be distributed into 3 equal parts, and 4 can be written as 1 plus 1 plus 1 plus 1, 4 boxes. So for x plus 3, this is 1 box, 2 box and 3 box. I'm taking here 1 plus 1 plus 1. This is 1, 1 and this is 1. So it has become x plus 3. For x plus 4, which is breadth here, this is, if this is x, so it has to be x. And we want 4, it means 4 equal box. 1, 2, 3, 4. This is 1, this is 1, this is 1 and this is 1. Now my dear champion, please focus. If this is x, so it has to be x and it will also be x. So we have a square, so side will be x square. Correct? And if this is x, so it has to be x, it has to be x, here be x. This will be x, this will be x, this will be x, so this will be x. But the interesting part here in these boxes, the black color one, my dear champion, if this is 1 width, so it has to be 1. And if this is 1, so it has to be 1. So this is a square. How many squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares. And the area is 1 square. Area of 1 square, area of 1 square will be 1 square. This is, let me decrease the sharpness. So this area is basically 1 square. This will be 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 1 square. 1 square. 1 square. 1 square. 1 square. We all know 1 square is equal to 1, but for your clarity, I'm writing there 1 square. So my dear champion, if we write the area, here area of largest square, which is the largest square? The bigger one. So what will be area? This is not square. I can write, this will be basically rectangle. So a square is not making any sense because length and breadth both are different from each other. So better to write area of what? Rectangle. Right? And here the side is x plus 3 and here the side is x plus 4. Right? So what will be the area? Length into breadth. And what will be the area of this? The area of this bigger square will be sum of the area of this square plus this rectangle, 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 square, 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 square. Wow. Yes, my dear champion. So the area will be x square plus how many rectangles? 1, 2, 3. Why I'm calling these as rectangle? Because length is x and breadth is 1. And this is also rectangle 1, 2, 3, 4. So 4 rectangles here and 3 rectangles here. How many rectangles? 7 rectangles. And what is the area of each rectangle? Length into breadth. Length is x and breadth is 1. So x 1 x. And how many rectangles? 7. So we can write here 7 into area of what? 7 into area of what? Rectangle of sides what? X and 1 plus what champion? Area of how many area? 7 squares. 12 square. 3, 6, 9, 12. So this is 12 into area of square having sides what? Side 1. So this is all about. And what will be the area of the bigger rectangle? Length into breadth. And length is what? X plus 3. And breadth is what? X plus 4. Now write, this is x square already, the area of this square, plus 7 into area of rectangle of side x and 1. So if the area of rectangle sides x and 1, it means length is x, breadth is y. So what will be the area? Length into breadth, x into 1, and x into 1 will be x. And here 12 into area of a square having side 1. So if the square of area side 1 is there, so what will be the area of square? 1 square, and 1 square, we can write 1 square. So we have x plus 3 into x plus 4 is equal to x square plus 7x, and 12 1 are 12. Can you please match the answer? What was the result? X square plus 7x plus 12. What is the result? X square plus 7x plus 12. Hence, prove that this identity is absolutely correct. We have proved by the help of geometry. We have proved with the help of geometry. So this is all about, champion. I hope you guys are now feeling confident. I'm making your maths very easy. Now can you see? This is x plus 6 and this is x plus 7. So what will be the result? First x square will come. At the center, both the numbers will added up. 6 plus 7 with x. And at the last, numbers will be multiplied. 6 into 7. This is identity. Now solve. X square, 7 plus 6 will be 13. X, 6 7 are 42. This is the answer. Clear, everyone? So thank you so much for watching this part 1 of one short series of exploring algebraic identities. I have tried my best to deliver you very easy teaching method so that you guys can ensure confidence in this particular chapter. Please watch the video and don't forget to recommend this channel, this video with your another 9th ninja, your friend, classmates and all, and stay connected with this channel. I'm assuring you guys, you all are going to score dream marks, everyone. So thank you so much for having me here, your Sonu Sir. Bye bye, everyone. Take care of yourself, take care of your parents, and don't forget to watch the part 2 also of this one shot video, and the part 2 video will be uploaded very soon on the channel. So until then, thank you so much for watching. Have blessed. Bye bye, and subscribe.